I love to make cookies for my family. What I do is I make a big batch of cookies and I put them in the freezer so we can put them in school lunches and eat them periodically throughout the week. So I wanted to let you know that I had about 5 cookies left in the freezer and I thought, I better make some more. So every single batch of cookies I make 12 cookies. So I wanted to let you know that that is my scenario here. Now, the table right over here, the X right here is going to represent the number of batches of cookies that I'm looking to make. The Y value here represents the total amount of cookies that I'm going to be having in the freezer for us to enjoy. So if I made 0 batches of cookies, I have to think, well, what is that going to give me? Well, if I made 0 batches and I didn't have any to start with, then I would have 0 cookies. But remember, I had 5 cookies still in the freezer. So if I made 0 batches of cookies, I'm still going to have the 5 that were in the freezer. Okay? Now, if I decided to make 1 batch of cookies, what that's going to mean is that I have 1 batch of cookies, 12 cookies total, plus the 5 that I had in the freezer to begin with. So if I did that one, I would have 17 total cookies. Remember, if I don't feel comfortable doing that here, I can always substitute in the value of 1 into the rule and do 12 times 1 to get 12 plus 5 is 17. And it looks like here too that I forgot to do the 0 just to clarify. So if I did plug in 0 or substitute in 0, 12 times 0, remember, no new cookies with 0 batches plus 5 is 5. Sorry about that, out of order. Okay, so let's go to 2 batches. Let's say I really want to make sure I stock up my freezer. If I do 2 batches of cookies, that's 2 times 12, which is 24, plus 5, which is 29. And then let's go ahead and take care of the 3. So if I, let's say, wanted to make a lot of cookies, I was going to send some cookies off to college with my daughter, I would do 12 times 3, which is 36, and then add 5 to get 41. Now, in problem number 1, we talked a little bit about direct variation. So we're going to try to see if this relationship in our table, situation, and equation represents direct variation. Okay? So remember again, the table shows direct variation when it includes 0, 0 and has a constant of proportionality. So let's go ahead and start off with 0, 0. As I look at my table, unfortunately, I don't have 0, 0. So even though this is a correct relationship, it's telling me how many cookies I have left, the only thing this tells me that it doesn't do is follow direct variation because I do not have 0, 0. In order for this to be a representation of direct variation, this would have to say 0, 0. I would have to have no starting cookies. Okay, let's just check to see if it does have a constant of proportionality. Remember, constant means that I would constantly repeat the same thing. Make sure that you clean your room, clean your room, clean your room, constantly repeating it. Proportionality, remember that keyword proportion means fractions that are equivalent, usually 2 or more. So let's go ahead and set up our constant of proportionality. If you remember when we did our rate for our babysitting problem, we did y over x to find the rate. So let's go ahead and test it out. If I did this, I would get 17 over 1. In this one, I would get 29 over 2. And for this fraction, y over x, I would get 41 over 3. Now, these might be a little tricky to know if they're equivalent or not. So, just so you know, I divided them. So 17 divided by 1 is 17. 29 divided by 2 is 14 and a half. And then 41 divided by 3 is 13 and 6/10. So if you notice, these 3 values are not constant and they are not showing that they're equivalent fractions. So this would be, we call it a non-example of direct variation. That means that even though this relationship has a rule, a scenario, and a table, you're going to still notice it's growing at a constant rate from 5 to 17. You're adding 12 cookies from 17 to 29. Every time you add a batch, you're adding 12 cookies, which it's still right here, that 12. But because it doesn't start at the origin or 0, 0, and it doesn't show that constant of proportionality, remember fractions that are equal, this is not direct variation.